We have an unbranded inverter mini-split air conditioner here. I am going to power it on. I will plug the air conditioner's plug into the power socket. Its display is currently showing a temperature of 16 degrees. If we check its standing pressure, the outdoor unit has not started yet, and the manifold gauge needle is around 290 psi. Now I will let this unit run continuously. The fault typically appears between 5 to 15 minutes, so I will wait for that. At the moment, it has reached its maximum current. It went up to 12 amperes, and then the amperes started decreasing. Gradually, they continued to decline. It went up to approximately 12.5 amperes. Now the amperes are starting to increase again. So the amperes in this unit are fluctuating in this way, which should not be happening. If we check the refrigerant pressure, it is proper. At this moment, the unit's pressure is 110 psi. This pressure is perfectly fine for the refrigerant, meaning the refrigerant condition in this unit is entirely okay. I will keep monitoring the amperes until the unit starts displaying an error. And now its compressor has shut off. I think it only worked for about 4 to 5 minutes. The amperes have dropped to 0, and the pressure gauge needle has also started rising. The display now shows an IR error, which is very strange. There is not actually an IR fault in this unit. Currently, it is showing 16 degrees on the display. I will change the temperature now, so please observe carefully. It has now reached 17 degrees. I am changing the temperature further. It has gone up to 20 degrees, but the full number 20 is not visible on the display. There is one line missing from the bottom and one from the top. Now it shows 30 degrees, but even at 30, 2 lines are missing. And now it is turned upside down into the letter I. This means the display itself is faulty, which is why it's not showing the correct error. So first, we need to fix the display. Then, we'll check for other faults. First, I will remove the display. Let me open the air conditioner's cover. Now, we can see if the LEDs in the display are working properly or not. On the left segment of the display, the upper LED and the lower LED are not working. The LEDs look physically fine, and I don't see any visible faults in them. I will now remove the display from the cover. To do this, I will push the lock to the back. This will allow it to come up. I'll do the same on the other side as well. And now the display is up. Let's clean it a bit, as there's a lot of dust on it. This IC is responsible for turning the LEDs on and off. It's a 14-pin IC, and its part number is HC164. This is a shift register IC. If there's a fault in this IC, the LEDs won't work properly. I will also check the resistors in the circuit to see if any resistor is burned out. Looking at the circuit, no resistor seems to be physically damaged or burned. I will go ahead and replace this IC. I'll use a hot air gun for this task. Now that it's out, let's apply a little solder paste on it. I'll clean the pins a bit to ensure the work can be done again easily. It's important to ensure that the pins are properly aligned and everything is aligned correctly here. Now, I'll use the full solder wire to solder the pins on the other side. On this side as well, I will apply solder wire once. All the pins are now clearly soldered. Now let's also disconnect the outdoor circuit from here. As I mentioned earlier, you need to keep an eye on the current because it was getting too high. This was happening because the outdoor circuit board was not detecting the current properly. That's why it was pulling in more amperes to check the system. Sometimes the current flow was high, sometimes low, but when it wasn't analyzing the current properly, it showed the EA error on the indoor unit's display. The manufacturer says that the EA error is related to the CT, or current transformer, so there could be an issue with the current detection circuit as well. Let me explain where the current detection happens. This entire motherboard contains not just one PCB, but 3 PCBs. This one is the power board, the left side has the PFC board, and the right side has the IPM PCB. The fault is in the power PCB. I will disconnect all the connectors from this board. Here, in this circuit, the current transformer is installed. If there's a fault in it, this PCB will face issues. However, it's important to ensure that the installed current transformer is functioning properly. By chance, if the CT or current transformer is okay, then the fault could be in the current detection circuit. Also, I have experienced that if short circuits happen, the microcontroller becomes faulty, and other functions of the PCB work correctly. Still, the current detection circuit or microcontroller does not work properly, but that happens very rarely. If it's okay, then there is no problem. First, we need to confirm whether the current transformer is working properly or not. Let's test it to see if it's good or faulty. There are 4 pins for this CT in this circuit. The 2 pins on this side are in series with each other, and the other 2 pins on the opposite side are also in series with each other. Both the pairs are not connected with one another. Let's check these pins first. The resistance value here should be very low. It is currently reading 0.4 ohms, which is absolutely correct. The first test we performed shows that thick wire passes through here. When current passes through here, a coil is present on the other side, which generates voltages in the coil. This means that a magnetic field is created inside the current transformer. Due to the magnetic field, the coil side generates very low voltages. The system uses this to estimate how much current is flowing through here. Now, let's check whether this coil is faulty or working properly. The value here is showing 4.9 kilo ohms, which is completely wrong. This means that the current transformer is faulty. Let me show you how. I have a new current transformer. The thick wire on top is the main wire, and the 2 points here are in series with each other. The smaller wires here are connected to the coils. I will show you what the proper value of this coil should be. Now you can see that the value here is 266 ohms. The original current transformer used in the system fluctuates between 500 to 700 ohms. When the coil resistance value reaches kilo ohms, it cannot effectively transform the required low voltages, making it faulty. Now, we will heat the old CT's pins and add solder to it before removing it from the circuit. I have removed the CT from the circuit, and now I will check the resistance value of its small pins. The resistance is reaching up to 7 mega ohms, which is a very high value, indicating that this CT is faulty and no longer usable. I will replace it with a new CT on the circuit board. After installing the new CT on the circuit, I will solder it in place. Now, we will check the actual resistance value of the new CT in the circuit. The resistance of the larger pins is slightly higher, around 1.2 ohms. The important part is the resistance of the smaller pins. The resistance value we observed outside the circuit remains the same after installing it in the circuit. Now, we will install this circuit board back into the system to see if it works correctly. The original current transformer had a resistance value of up to 700 ohms, so this difference is acceptable. If it operates correctly, it means that a resistance value between 300 and 700 ohms indicates proper functioning. I will now power on the unit and turn it on using the remote. It has started working at 16 degrees. At this moment, the amperes are 0, and when we check the manifold, the needle is completely stable, showing a standing pressure of 310 psi. Now the unit has started, and the outdoor fan was the first to turn on. The compressor has also started up. At the moment, the unit is drawing 0.9 amperes, and now it has increased to 1.2 amperes. Since the current detection is now functioning correctly, the amperes are gradually increasing. Previously, it would rise very quickly. The refrigerant pressure is also dropping steadily. When I check the cooling, it feels adequate and effective. Currently, the unit is drawing 6.6 amperes, and the cooling performance is good. The sudden increase in amperes is no longer an issue because the current detection system is now working properly. The unit has reached 8.8 amperes, which is its maximum amperage, and it will not exceed this limit. The amperes might decrease, but they won't increase beyond this point. This is why I emphasize monitoring the current closely. Now, we will store the refrigerant in the outdoor unit. First, we will close the discharge pipe. After closing the discharge, the manifold needle starts to drop. Next, I will close the suction tube, but it must be done within 1 minute. Finally, I have also closed this valve. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.